All right, Objective 6.2, ratios and similar polygons. Today we're going to talk about similar polygons and why they're important. So figures that are similar, and you'll notice the little symbol there that we'll use for similar figures, have the same shape, but not necessarily the same size. So if we look at our example here, 1 and 2, triangles 1 and 2 are similar. They have the same shape, but they're obviously not the same size. 1 is a smaller triangle than triangle 2. If we were to compare triangle 1 and triangle 3, 1 is still smaller than triangle 3, but it's pretty apparent that right here in that corner that I've highlighted would be a right angle. And in triangle 1, there doesn't appear to be any right angles. So here's the key. Oops, it's not what I meant to do. Here's the key statement. Two polygons are similar polygons if and only if their corresponding angles are congruent. Let me write this in blue. Remember, congruent means same shape and same size, and their corresponding side lengths are proportional. So we're going to have figures that have the same shape and the angles are going to be exactly the same. But when we compare their side lengths, those side lengths are going to be proportional, meaning when I create a fraction with those side lengths, they would all reduce down to the same simplified fraction. The best way to explain this, I think, is just to jump in and do some examples. So if I'm given this statement that triangle ABC is similar to triangle DEF, I know from the similarity statement that angle A and angle D are going to be the same size. I know that angle B and angle E are going to be the same size. And I also know that angle C and angle F are going to be the same size. They're going to be congruent because that's the order that they come in their similarity statement. Now what I have to figure out is the ratio of the sides. So the ratio of the sides is going to be the same way. Like when things were congruent, we would put them according to how they appeared in order in their name. So AB. AB is the first two letters in the first triangle. DE is the first two letters in the second triangle. BC, let's change that to red. BC, it's here. It's here. So then EF would go there. All right, and then the last side of that triangle is CA, FD. So CA, FD. Now, if I wanted to know what they would, I'm going to erase this just a little bit for a second so I can see my numbers here. So I'm going to go back to side AB. AB is 18. DE is 45. BC is 10. EF is 25. CA is 15. And FD is 37.5. So what I'm saying is that when I simplify, I'm going to go back and color code these again so that visually you can see how the sides are going together. Now they won't always go around in the same direction. This one was just kind of nice that it all went around in the same direction, but some of them are going to be flip-flopped a little bit. So when I simplify these fractions, I should get the same thing for each one of them. So 18 divided by 45, 10 divided by 25, and then 15 divided by 37.5. I got the same number each time that I simplified, each time that I typed in those sides, I got the same number. Now, that number has a special name. It's called the similarity ratio. A similarity ratio is the ratio of the lengths of the corresponding sides of two similar polygons. The similarity ratio of ABC to DEF is 3/6 or 1/2. That's in this new example that we're given us. And this example that I just did, that similarity ratio, let me pull my calculator back up. Notice how it gave me a fraction, it gave me a decimal. Well, I want to hit my little button over here and get my fraction. So for this one, it would be 2/5. Okay? For this new example, my similarity ratio is 3/6 or 1/2. You've got to always simplify. So for the first problem, I started at ABC and I went to DEF. So you start with the 3 on top and the 6 on the bottom. For the second one, I started with DEF, which is here, and it has the number 6, and that's why the 6 is on top. And when you're going to ABC, the 3 is on the bottom. All right, now we're just going to do some practice problems. So I've got two triangles shown are similar. So if these two triangles are similar, it wants to know the scale factor of CED to TVU. So CE is 9, TV is 27. When I type that in, 9 divided by 27, I get a decimal, 1/3. Now all I'm doing is hitting this little button over here on the left-hand side to make that decimal and fraction rotate back and forth. So D would be my answer. Now I want to write a similarity statement. It's just like writing a congruent statement. We're going to determine whether these two polygons are similar. We're going to say that yes, they're similar. However, in order for me to really say that they are similar, I would have to know that all 4 of those angles are congruent to all 4 of these angles. All right? I'm going to take that as a given. And then I have to see if the long sides, which is 9 and 6, if that is the same as 6 to 4. So I'm saying this 9 and this 6 with this 6 and this 4. Now when I simplify those, do I get the same number? Well, let's see. 9 divided by 6 is 1.5. 6 divided by 4, 1.5. So because these sides simplify to give me the same number, I can say that these are similar. Now, the one little thing that I'm doing is I am assuming these polygons are both rectangles. All right, so my similarity statement, A, B, C, D. Is similar to E, F, G, H. All right, my next example. Determine whether the polygons are similar. If so, write the similarity ratio and a similarity statement. Okay, well, I got to figure out here these missing angles. Now, this one's a little bit trickier. A 10 and a 10. If two sides of a triangle are congruent, I have an isosceles triangle. That also means that these two angles, P and R, would also be congruent. So to figure out what those two angles are, I'm going to say x plus 36 equals 180 degrees. Why 180? Because I'm working with a triangle. That's why. Everything with the triangle adds up to 180 degrees. So x plus 36 equals 180. So what is this? X is 72. So each one of these angles down here is 72 degrees. Okay. If those angles are 72 degrees, same kind of thing with this other triangle. Let's look at it. I got a 5 and a 5. So if two sides of a triangle are congruent, I've got an isosceles triangle. That means that both of these angles down here at the bottom would be congruent. Both of those angles are 62. How would I find angle T? Angle T would be 180, subtract 62, subtract 62. Let's see what I get. 180, subtract 62, subtract 62. I get 56. So that's 56 degrees. So, in order to say that two polygons are similar, polygons, by the way, is just a shape. Triangles are a very specific polygon. But in order to say that two polygons are similar, all of the corresponding angles, all of the angles in one triangle have to be exactly the same as the angles in the other triangle. Do these three angles match up? No. No. These triangles are not similar. So sometimes that happens. Determine if these figures are similar. If so, write the similarity ratio and a similarity statement. All right, M and N are congruent because they have the same mark. L and P are congruent because they have the same mark. What you have to remember is that if two angles in one triangle are congruent to two angles in another triangle, then that third angle is also congruent. So my angles all match up. All right? So that's good. Now, let's see if the sides are proportional. All right? So LM is between the 1 mark and the 24 degrees. So 60 would pair up with 24. All right? And then 75 would pair up with 30. And then for the last one, let's go purple. 45 and 18. So let's see what happens. 60 divided by 24. 75 divided by 30. Oh, so far so good. 45 divided by 18. All right. So I got 2.5 each time, but in order to have a similarity ratio, I have to have a fraction. So I'm going to hit my little button, and I get 5/2. So I'm going to say triangle JML is similar to triangle SNP, and the similarity ratio is 5:2. Now, yeah, I could have named the triangle a little bit different. That's okay. I hope you remember that. All right, my numbers are a little funny here. I'm not real sure why. Given that these two triangles are similar, what is the value of x? Uh-oh, let's see here. So RV goes with UK. So RV is 30. So RV to UK. VW to KJ. And let's go with green. WR to JU. All right. So those are how my sides match up. Now I'm going to look to my triangles, and I'm going to place the numerical values in for those different sides. So RV, UK. So I've got 39 over 2x minus 21. Now I've got VW, which is 27, KJ, which is 9. Now, a couple of days ago, I spent all day just typing in problems like this and solving. So let's see what happens when I try to add WR. WR doesn't have a number with it, and neither does JU. So it doesn't have a number with it. That's just some extra information that I'm just not going to use. I'm going to go back and do my first step. Cross multiply. Oh, this is getting messy. Let me write it over here. 27 times 2x minus 21 equals, and then multiply here. All right, that's my first step. I cross multiplied. And so now, type that in. Remember to use the parentheses or I'm going to be in trouble. Equals 39, parenthesis 9. X is 17. Is that what my problem wanted me to find? Yep. What is the value of x? It's 17. Last example. There's a number. Yeah, these numbers are weird, guys. Sorry about that. All right, ABC is similar to DEF. So AB, DE. BC, EF, and then CA, DF. Okay. There we go. That way I can see my numbers right there. So let's set up my proportions. X over 14 equals Y over 17. And now blue, 57 and 19. All right, so x over 14, y over 17. I have to find x and y, but I can't find x and y if they're both in the problem. So 57 over 9, I'm going to have to break this into two smaller problems and use that 57 over 19 both times. So my first problem, my first proportion that I'm going to set up is going to be this. So x over 14 equals 57 divided by 9. That's my first problem. Cross multiply. 19x equals 14 times 57. I'm going to type that in. 19x equals 14, parentheses 57, parentheses. X is 42. All right, next problem. Can't see my colors. Green. I'm going to say y over 17 equals 57 over 19. Cross multiply. 19y equals 17 times 57. So let's go over here. Change this just a little bit. Equals 1757. Y is 51. That's it, guys.